Looks like this one's up and running. I have done some work while I wasn't streaming anything. I thought it was going to be a lot slower, and honestly, some of it was. I was running into some issues with builds, and builds were taking a while. One thing is I needed to remove all forms of edit in any place where it was non-editor code. That was something I could get away with at the beginning, but I had to do compilation tests and found I had a variety of spots I needed to fix. Um, on top of that, I also had a size limit. I also had a size coming out on the build of 2.3 gigs, which honestly it should not have been anywhere near that. And also, I'm planning on releasing to itch.io in the first place, which itch.io has a 2 gig limit. So I started taking a look at what I could do to clean up and remove things. So the first thing I did was I went to one of the asset cleanup tools. I actually tried two of them, Asset Cleanup Pro and Asset something or other Pro. But anyway, let's remove this. And I'm still getting some extra things here. I'm not sure what's going on with this, but I think it might have to do with Asset Hunter Pro. I want to remove this. Remove assets from project. Yes. Uh, yes. Maybe I cannot. All right. I've also got the asset hunter down here. I'm going to remove that one. I've got two different asset hunters in here. Um, get rid of that one. I wonder why it wasn't. Locate. Supposed to be in this part, which it's still there. So, oh, whatever. Oh, I'm on these ones. So remove. Yes. I think what's happening is that the asset hunter is doing a bunch of updates on this while I'm using it. So I keep getting these updates that are happening, and it also happens to clear out the console logs, which has been a terrible practice. Anyway, I ended up finding out that the majority of that all came from textures, and I didn't have that many, but most of them were bumped up to 4K. And so I kept 4K on the albedos, on the primary color of the material. But then I used 1K on all of the other textures, like the normals and everything else that's in it. There's like 6 different textures for each one. And so that was easily taking upwards of like 50 to 100 megs for every single texture, for every single material. And there were a decent number of those. So clearing that out and reducing the size of the materials the size of the textures that I was using for some of the other non-essential ones. A lot of people tend to see like the texture differences where you have a shader and we've got our normals, which kind of deals with how the reflections work. And then we've got and a variety of other things. But then we also have the albedo. And whatever the albedo is, a lot of people and designers will put the exact same size in for normals and for other things. However, a lot of times that's not necessary at all. And when it is necessary, you can still cut the resolution a lot of times by just making sure that the alignment of where your textures are in a nice even spot at a lower resolution. So it cuts off from one to the next one much easier. All right, did I get everything? No. Remove this one as well. Yes. And the only other one in here is Asset Hunter Pro, which I think was just in the root assets. Anyway, so I tested the game. The game's down to 0.3 gigs. So I cut out 2 gigs of content from the download size, and now I've got plenty of space to work with again. Not that I'm planning on filling it all up with a bunch of useless stuff, but I will likely fill it up with some extra things. Or some things that'll be nice to have. Okay, I don't see any of the cleanup stuff in here anymore. Hopefully I won't be bothered by it anymore. Let's see now. Scene view. Some of the resolution differences, I mean, you can kind of see here. Before, that didn't stand out so much. It wasn't kind of curved and rounded there. It was more squarish. However, most of the time when we are driving around, this stuff is, we're going by it fast and we don't really notice it. We're seeing most of the world like this. All right. Okay. Now, the area that I'm working on right now is that I need a procedural mesh. If I'm using this mesh system and doing it by hand, that's going to be a pain. I've considered the size of the world and like all the work it took to put in all of those positions, and then I'm zooming out. And even if I have help, the thing is that when you look at all of these individual building areas, every single one of these represents complex tunnels and pathways that would take a long time to develop or to for someone to go through manually and start to add all these. Trying to add a nav mesh manually through all this, that would just be a pain. So I'm going to be generating a script to produce this. It's worth the work now that I'm at now that that's my blocking point. All right, so scripts away. Vigilante 24. Why am I seeing the project in this format? Give me one column layout. Thank you. Now I need a texture. Get rid of that one. Oh, wrong one. Vigilante. I need scripts. Now, with this one, the system that I'm working with is design, traffic designer. So now I need another tool to go along with traffic designer that's effectively going to auto populate all of that data. Now, I'm also going to need to expand on the traffic systems to automatically pool. They're going to need to pool now, and they're also going to need to remove things at distance and re-add them within range. All right, so now let's go traffic system, traffic designer. Let's create a new one. I'll go to traffic system, control CV, and the new code will be called traffic procedural traffic designer. Procedural traffic designer. All right, now let's bring up this stuff. No. That one, that one. Okay, now this is a lot of duplicated data. Again, stuff that's not used inside of the rest of the code or not used in the runtime, so it's all removed. Let's go over to this one. No idea what that says. There. All right. That one. It's live. Yay. Pause it. Now, can I edit the video? Take me to the tools. That's not what I want. I'm just trying to get over to my channel content and see the live stream so I can get to the editor view for it. There. Awesome. Next, back over to here. There's lots of information that I don't need, so I'm just going to get rid of it. This is a really long file. I should have started with something else. All right. No. There. Cool. All right. Traffic system. I can get rid of this one too. Yeah, this one won't even need an editor. Mono behavior edit in base. I don't need it to end if there. We just won't have this. I've never considered the idea of if I am trying to create a script that only is going to exist in editor, can I just wrap the script in this? Will it complain during build? I honestly don't know yet. Worst case, I'll shift the if Unity editor to inside of here, but this lets me test this anyway. All right. So my next section on here, procedural traffic designer. There's a couple concepts with this one. Where's my notepad? I had some notes that I put in here on it. This one. I'm going to put these inside of here. There. No. Had some weird tabbing, but I suppose that makes sense since I thought this was all code. Okay, so for the procedural design, what I'm effectively going to do is go through every single vertex within the world, and I'm going to I'm going to basically add all of those vertices to the list of what we're going to display. However, we're going to be then massaging it down and connecting data and altering some of the fields. So here's the overview. For every vertex on the mesh, we're going to add a node. This will just be in memory, not added as something like a game object or anything like that. So now for every vertex, we're going to store a point in memory. We're also going to store the normal for the face that it was attached to. So every mesh is broken into a bunch of triangles, and every triangle then has 3 points on it, 3 vertices, and 1 surface. The surface or the face of it has a normal, what direction that is facing towards. And then we also have the points. So I have 3 points all with the same vertex or with the same normal. So I'll be getting that. And basically this is how I get it. I get it from the triangles list from the mesh based off of the vertices. And then that gives me the 0, 1, and 2 positions of the triangle. And then from there, I can get the normal by doing a cross product of V1 minus V0 and V2 minus V0 normalized. That gives me what direction the triangle is facing. Next thing is I want to go through every single point that has been generated, and now I want to merge them. So if I find ones that are close enough, like within a meter of each other, I'm going to join them together. That way, all the connections will be connected to the same points from whatever each of those points were. And then I'm going to do a raycast detection for the last part of it. The raycast detection is that sometimes where these meshes line up, there are points where some of one mesh covers another mesh. And that's not going to be helpful to me. I don't want any of the mesh design within that system. All right. I only want the vertices or these points where they're going to be exposed, where a car can actually drive. If I produce one outside of it, I could produce a car outside of the boundaries of the world. All right, so now let's start gathering the information I need. First thing, I need to get a list of the game objects that contain the environment for the world. So we're going to do public list game object and environment colliders. Environment colliders root. All right. So inside of the scene, we have 6 different root objects that they don't have colliders themselves, but they have lots of child objects that then have lots of colliders inside of them. And so I want to gather those colliders. So now I need a way to trigger this. For now, I'm just going to put in public bool underscore uh, try equals false. All right, and then public void on validate if underscore try, then underscore try equals false, and try build, try bake, try bake. Bake is a reasonable keyword to use here. All right, so now Bake needs to go through each one of the meshes and gather the information for it. For this one, I'm going to use class objects for this because this is design time. I can take some extra development time of it, especially when I'm early in the design part of it, development phase, because as I improve on this later, I might make plenty of decisions to change things. So using some structures that I'm going to change around for performance, that's just fine. But I want to build for ease of change right now. Public class, and this one we need information about what's going to be stored for each one of these objects. So we need a node. We need to know its starting position, its offset, or its distance. Oh, for its distance, I need to store that. That's going to be public float surface distance, similar to what you might call a step distance in the nav meshes from Unity. Around 4 meters is what I've been finding works pretty well with this system. Float. Oh, M. 4 meters, I put a literal M there. What does M change it into? Decimal. M changes it to decimal. I thought that, oh, is double, isn't it? Yeah, that's double. Okay, well, M goes to decimal. This is UINT, correct? Which can handle a conversion. It doesn't show me. All right, whatever. That's not important. I just need that one to be 4 to begin with. So now inside of here, I need to be able to store for every one of these points, I need to be able to store the position. I need to be able to store where it exists, or sorry, the position, the normal, the and a list of all the other connections that it can talk to. Where those connections exist? How am I going to handle that when I've got a variety of connections that are going on? I could produce more sets of data. The problem is that when I'm going through this and I'm generating what is it connected to, I can't generate an index for what it's connected to begin with because I don't know what those indexes are going to be. Actually, at the beginning, I do. Every single one of these gets an index. Every single one of these, when I'm going through it, is based off of its position in the triangle. So I know that there's going to be 3 added at the same time, and those are my only connections to begin with. I'm not worried about merging with ones from other positions until later. And then by that point, I'll have all the indexes set up. So I can identify if this goes to index 0 in the triangle, then that's index whatever offset I'm on within the list of points plus the offset of within the triangle. All right, so I can do this. Public class node, that'll work. Now, public vector3 position, public vector3 normal, public list. And this was going to be a list of connections, but which, in other words, just listing the nodes. I could just list the nodes. I don't need to know all the rest of the information. Not yet. No. Let's keep this a little bit lighter weight. Int. Otherwise, just saving the data within the scene is probably going to take forever because it has to serialize that whole structure down to YAML. But if I can have this just as a list of numbers instead of as a long list of vector threes or object references, I'm imagining the lookup speed will be considerably better, especially when it deserializes. Honestly, I don't actually know if it will be better or worse, but integers have to be better than YAML, or integers for lookup have to be better than object references because the integer is just an index in the array. Okay, so over here we have list int connections. All right, that works. Now, list of connections, when I start merging things, I have to identify that they're merged. In this case, if I go by index, then all of those offsets will get thrown away as I start discarding objects from within here. But I also need, I've got a long list of cross-reference needs within here. Okay, so list of connections, do I just start marking them as indexes between? Maybe. Okay, separate indexes. I'm going a separate index route. So in this case, what I mean by that is that I have a class node here that stores, here's all the different nodes, the position in the normal, just like I've been doing with the designer data. And then I also need to store the connections that are going to be in there as their own separate list of integer to integer. So public class. And if that's the case, wait a minute, isn't not my save data, but my designer data? That one should actually match pretty close to what I'm looking for. So procedural traffic designer, and now I need the traffic designer. Traffic designer. What is traffic? Traffic, car, traffic connector, truck connector. Designer traffic data. Okay, so designer traffic data has a node with a position and a normal, and then an index map. Basically the exact same things I'm looking to use right now. It's a scriptable object. It stores a list of the nodes, which is itself, its own structures, and a list of index maps, which is, a list of the connections here. So effectively, it's the exact same data that I need. Okay. I will use an instance of this that gets stored in memory. I could actually just fill the data to begin with. I can just use the referenced one. Okay, let's go with that route. I don't need this one up anymore. Not in car action. Baked traffic, no. Where'd my drop-off system procedural traffic designer? This one. Okay, so the data I no longer need to maintain. That was going to be these ones. Ended up with the exact same data structure. Makes sense, I guess. Public, and now I need a reference to this data structure, which was designer traffic data, traffic data, traffic design. All right, so we got traffic design. We got to try, now we're going to try to bake this. So the first thing we need to do is clear all the information inside of there. So let's see, do we actually have a method built in to take care of that right now? Inside of here, no, we don't. And that should be handled by this. So let's go ahead and create public. With this one, I do want to reset the data because it's procedural. It bakes the whole thing. It's not going to be additive. So public void clean clear. And now inside of this, we have nodes and we have mappings. So I don't care about, there's two ways that I can do this. I can just say public. You know what? I don't care. I don't care for performance right now. We're just going to say nodes dot clear. Sure, that works. And mappings dot clear. Was there any other field inside of this? Distance from surface, I'm keeping that. Baked traffic, I'm not going to touch that with this one. All right, cool. That takes care of what I needed from this. And I suppose as long as I just clean up the data, I start with a much wider amount of data and then I start cleaning it up as I go. That should work pretty well, except I can't add nulls since those are structs. We'll see. Maybe I can use it, maybe I can't. Procedural traffic designer, and I need to put this somewhere. I don't need all these classes up anymore. Let's get rid of anything I don't need. There. I got rid of one of the things I didn't need. Okay, procedural traffic designer. There we go. Now, try bake. We need to go through every single mesh attached to every single one of the game objects I've referenced within list game object. So now let's say public, not public. We need to go through each. So for each var go in ECR, environment colliders root. Now inside of this one, I want to find every component within children. For each var filter in go dot get components in children, and that type is mesh filter. Now that includes the parent, I believe. It doesn't specify, but whatever. It doesn't matter. The root objects don't even have mesh filters on them. So I'm getting every single mesh filter. That's every mesh that's attached to each game object. Now I want to go through every point on it. I need to get the mesh. So var mesh equals new. Var mesh equals new. No, mesh equals filter dot mesh. Does this do instantiation? There's a couple of these that generate the object when I request it, at the time that I request it. And I think shared was a way to get around that. I don't need to know anything beyond it, so I think shared mesh will be fine. All right, next, if all of my points are way off, then I guess I will need to do something different. So now var mesh, so we've got the mesh. What's next? After we get the mesh, now we need to get the triangles. We need to get the vertices. Now, inside of this, I was, left myself a couple hints in the code. I usually find it useful, like if I'm rewriting this, it serves a different purpose from other code that I've written in the past that worked with normals, and remembering the sort order of what goes into the cross product to figure out which one of the triangles to get, sometimes that can get confusing inside of the code. So I like to go grab a copy of that and not do that part by scratch or from scratch. But the rest of the code is unique to this design. And so I want to recreate this from scratch for that purpose. Okay, so now to get this information, I need the mesh. So mesh.vertices. Yeah, good. There's the data. we need each one of the triangles. We're going to grab all three triangles together and we'll be adding these together. So var var v0 equals mesh. I don't need transform point. That's within worlds. I need this within world space. Okay, that's correct. So mesh dot transform, not mesh, filter dot transform, because filter is still a component, so it has a reference back to the transform of the object. So filter dot transform point, and that needs to be from vertices. You know what? I can just copy this part. Did I just change the order? I did. Get back up there. I didn't know I could do that. Holding Alt while you move the arrow key up and down moves the line that you were on. Okay, but anyway, var v0, v1, v2. And now inside of this, we have these need to be mesh dot, mesh dot, mesh dot, mesh dot, and same thing over here. Why am I writing it this way? That's better. Okay, now it wants I. This needs to be a for. Oh, duh. I need a for loop here. For and the up is going to be the mesh dot triangles dot count. And in that case, we take the triangles, we're getting that position, so it's I plus equals 3. So we get each 3 points, each 3 vertices within the triangle. These 3 pieces, or these 3 lines of code need to be moved into here. All right, so we now have the vertices, and I'm just going to copy this face normal over here too. Okay, so now what do we got? Time, it's just about midnight, so I'm going to be calling it a night in a few minutes. But let's see if I can get this data into place first and see if the points, if I can render the points and if they look like they're overlapping parts of the city to begin with. Let's see, for that one, I'll probably do just 10,000 A-line points. Oh yeah, we should put that in here. Public Boolean gizmos. It's false. Whether or not we draw will be enabled or disabled. Also the count. Public int draw count. Equals 1,000 to begin with. That's not going to affect how many we're actually loading at this point. We're just going to go through everything. Okay, so now that we've got these pieces of information, we need to start generating or storing that within the traffic design. So traffic design dot baked, not baked, dot nodes equals. And nodes, I should have a function in here that when I add something to the nodes, it gives me back the index that it just put in there. So let's go back to this, F12. And over here, we've just got a nodes add. Let's go create a new node function. So public int add node. And that's node. Don't care about any of the other information, just has that. Oh, and node there. Did this have a interface? No, it doesn't have an interface. Okay, so add node, and this is just nodes.add node. Excellent. Why does that have a red underline? Return statement is return nodes.count -1. Good. All right, so int I equals, not I, index. And this is, we'll call this n. There we go. Int n equals node design dot add nodes, add node. Okay, now I need a new node, traffic designer dot node, and the data inside of here. I should just return the node, but the index is going to be potentially more useful. Okay, what data needs to be inside of this node? So we need the normal and the position. Okay, so the position is v0. Oh, position. Oh, these are parameters. Normal, and that's face normal. Should be equals. All right. That gives me that one. That's all that it was supposed to contain when I'm constructing a node, F12, right? The node only has position in normal. It is the index map struct that has A and B for the connections. All right. And should I double up connections? In other words, by doubling up connections, should I double the memory size by storing the information in both directions across the array, or look up the data by looking up both sides of it? Look up the data by both sides. Doing a check on each one of them for each side of the record, for each direction of the record, that's not going to interrupt the order of the memory seeking, which means that the second one where we're reading one of them will effectively be free. Even though the streaming of the data will be much closer to free anyway, we'll get a better performance out of this. Okay, so normal, face normal. What is next here? So we got the face normal. We also need to store the connections. Okay, let's store the connections. Let's call this one N0. The next one is var N1 equals, and we're going to do the same thing again. Let's just copy this one instead. Control C, V, V, V. There we go. Get rid of N1. Now N1, or N2 and N1. This one is 1. This one is 2. Okay, 1 0 0 1 1 2 2. Okay, so now I have those new positions that are stored in there. Let's organize the data just a little bit. There. Now that I have each of those, they're already added inside of the node structure. Now I need to create the bridges or the mappings. So now it's going to be traffic design dot nodes, traffic designs dot mappings dot add new index map. Okay, now we need A equals V0 comma B equals V1. Oh, wait, this was, yeah, we're connecting 0 and 1 together. How did I do the other ones? Why is this looking so weird to me? Oh, lowercase v. Why is it complaining? Int to target type int v0 n0. That's what I wanted, n0 and n1. Okay, now we're going to do this again. Control C V V. There. So n0 to n1, n0 to n2, and n1 to n2, and n1 to n2. Okay, that adds each of the connections, so the triangles all have a connection back and forth to each other. Technically, I didn't need it for this part of the test. Okay, now let's go to the update in here. And I do need a design time update. So let's go public update, public void update. Now inside of this is execute in edit mode. Yes. Selection base. Doesn't matter. All right, so next, public update. And now inside of this one, we need the A-line draw functions. So that's draw for int equals I, for int I equals 0. I is less than, and what's my count? Draw count. I plus plus. Okay, we've done absolutely no cleanup of the data. We're simply storing the points. I am letting it go through every single mesh because I also want to see what the total counts are. That might take it a moment for it to process, but it shouldn't take long. All right, so for int I equals 0, I to draw count. Now I want to start drawing all those positions. So draw dot line. Where's my drawing code? It's not a line. What was it called? That's procedural traffic. I need traffic system. Traffic designer draws out all these lines for me. So in traffic designer, I am using the correct stuff. So that's using drawing. Okay. Okay, so within the editor, we are using drawing. These should all be inside the editor. Yeah, this script is only supposed to exist for use in the editor. The only one that should be outside of it is Unity Engine for the mono behavior in case I have to move this inside. All right, now execute in edit mode. Yes, so that'll allow the update to fire while we're editing. Next, draw. Draw. Oh, switch it to underscore draw. There. Try bake. Okay, that one was done. Oh, yeah, got it. If not underscore draw, return. Okay, so if we don't want it to draw, then we're not going to have it draw. Now, on this one, we need it to draw, and that is draw dot. What are we going to draw? Oh, here we go. Solid circle, but it needs a normal. It needs to know the direction to face for the camera. I wish this one would take care of that itself. Solid sphere. Do we have a solid sphere? No, that'd be expensive. Solid box. And it doesn't care anything. This cannot be used inside of burst jobs. Sure, whatever. Okay, so now what do we need? We need a center and a size. And potentially a color is an option too. So center colon center Okay, well, we'll skip the color then. Okay, so draw, and now we need center is what? We're getting this information from the nodes, which is inside of traffic design. Or another reason to exit early is because the traffic design equals null. All right, equals traffic design dot nodes dot. Ooh, okay, let's do this. Uh, int max equals draw count. If traffic design dot nodes dot add the nodes, these are individual positions. Okay, even though there may be some overlap here, add dot count is greater than draw count. It is less than draw count. Is less than draw count. Then we need to reduce draw count. Max equals traffic design dot nodes dot count. Okay, we limit the maximum that we're going to draw here based on either what our maximum is or the how many we actually have, whichever is less. Okay, center over here now needs to get the specific node that we need. So that one is going to be I and dot and position. Okay, that draws the solid box, comma. Wait, what other information did you need? The other one was size. Size equals 2f. Okay, that should work for now. Whatever color it is, it should be visible enough to see. Save it and return to Unity. Give it a moment to compile as well. Okay, compiled, but give me back control. I've been running into this thing where I get this window that keeps coming up and I haven't figured out what's causing it yet. But all sorts of things are causing it to trigger. Okay, so now I do need new data for it to work with. So let's go over to data, and in this time we need runtime. So we've got different traffic information. I'm going to take the car traffic designer, where is the car traffic? Oh, I can't see it by selecting that one. That's fine. That was selecting this one. Why can't I see any of the lines? Oh, there it is. I was upside down. Cool. All right, so traffic designer is there, and we got information way down there. Wait a minute, am I unable to see any of it from here? Oh, it should be right here. Control. Oh, there it is. I had to have it selected the correct way to do this. Okay, now I can see the lines of the selection of what it did all throughout this. Now we need to start printing circuits. It should print it from like one corner and start building along one city area. So let's add the new component to this one. That one is over in systems and it is procedural traffic designer. Now inside of this one, we also need to know what traffic system we're going to provide. So let's keep the sample one that I've got. So we've got car traffic right now. Let's go to Control CV. Nope, designer. Procedural. Okay. Now it needs the data. It needs to know what we're referencing inside of this one. So go back into traffic designer procedural. And we're also going to place that traffic designer procedural Oh, come on, expand out settings. Thank you, right there. Now, Traffic Designer Procedural was cloned off of the other baked data, so I'm going to have to produce a new baked data for this because I do not want to accidentally overwrite all my original data until I know this is working. So inside of here, Vigilante baked traffic. We're going to call this one car traffic baked procedural. Now, car traffic procedural needs to know where it bakes to. And there we go. Let's clear out the data. It's going to clear itself out. That's fine. We're at 14 and 21 right now. Oh, how do I trigger this one now? We go over to Traffic Designer. And what things do we have? Environmental colliders route. Oh, yeah, I need to know where to connect it. That's going to be over here on A, on B, on C, D, E, and F. These are the collider zones A, B, C, D, E, F. Good. 6 of them. Next, I have the surface distance 4 meters. I have the traffic data, which goes out to the procedural instance. I have the try function. I have the draw function. Draw should do nothing. No errors, no complaints. Save the scene before I have it do some large manipulation. Okay, and now the draw count is set to this. I don't want to bake. No. I want to try. Now, at this point, everything... Did that actually do something? I can't see the data right now. So let's go to car traffic procedural, right click and properties. It did clear the data because before it had plenty of data built into it already. Oh, this is the baked traffic. That's not what I want. Car traffic procedural. Car traffic procedural. This one. I got another. Hold on. I didn't do anything, but okay. Properties. Oh, that's it. Yeah. 329,000 mappings, 329,000 nodes. That it definitely got the data it was looking for. Okay, let's leave that minimized and not look at this data. Okay, go away. Traffic designer. So we've got a grid. Okay, let's get inside of there. We're drawing 1,000 points of this grid right now. What is this? This is not accurate. That doesn't align with anything. The transform point. Okay, this one is transform point. Wait, I think I want the inverse, don't I? I want to transfer from local to world space. Okay, so let's go over to our try bake because this was obviously incorrect data. The actual processing of this went pretty fast considering there were 300,000 points it was navigating. All right, so inside of this one, traffic transform point. And what does this one do? From local space to world space. So in this case, I have taken the local point and converted it into a world space point. But I'm also doing this against the shared mesh. Let's try it against mesh. Maybe there's something specific about it or about the instance. Okay, so yeah, we grabbed that mesh instead because right now my information is way off. And also, if that code is incorrect, that means that the code that I grabbed it from is incorrect, which means that that was likely an incomplete copy. All right. Transform. What did I have? That transform from local space to world space. Yeah, that should still give me the world space. So why? Why do I end up getting something that doesn't line up with reality? So I'm taking the points from the triangle. Let's try it with vector just to make sure. Transform vector. But I'm pretty sure point is exactly the item that I'm looking for. So if that's the case, why is my offset so far off? I'll come back to that one in a minute. Well, actually, I can look at the positions that it's trying to draw. Okay, exactly the same pieces of information. Now, do I see any, does that give me semblance of anything? So right now I'm just drawing 1,000 items in here. Let's change this. Let's turn off draw. Let's change this to 10,000 and see how this affects. Okay, I'm still getting it. It's still drawing it. It's kind of jittery and painful to watch. Okay, let's turn that off. Let's go to 100,000 and see how it draws. Wait, what's that? Wait a minute. Those are the other data fields I set up manually. Why are they rendering like that right now? If it's supposed to show 100,000 points, you know what? Let's go to 1,000,000. There. That's definitely slower, but that would encompass everything because there were 329,000 points that showed up. Obviously, that doesn't have everything. But why then? Like a lot of these are duplicates, but why am I seeing those ones down there when the data is supposed to be cleared out of that object? Okay, let's stop drawing. Set this back to 1,000 because that's obviously incorrect for where the data is going. Now let's go take a look at what it's drawing. So if I were to select, where's this? The traffic data, I need the designer traffic right there. What? Why does traffic procedural show up as 14? Okay, there, that's better. That's what I was expecting. Now nodes, expand. Okay, good. Look at that. That is really fine-tuned for the position. The other ones, they're kind of wildly out there, but and then this one, what's going on with it? This one is really far out there. There's some other ones. Are they okay? Still not super far because this is like a 5,000 by 5,000 meter area. Huh. All right. This is a good place to end it for tonight. I am getting data in here. I do have meshes that are showing up. I still need to go through and massage the data, and I need to make sure that I'm actually getting the right data. This stuff should be aligning to corners of the buildings right now. I don't care which buildings. I can figure that out by zooming out far enough. Oh yeah, and where is that? The traffic designer. And inside of this, we got 1,000 and draw. Yeah, look at that. It's drawing the other side of that too. Where did it get this data? It didn't clear it. That's it. I never called the clear function. So if I run this more than once, it's just been growing the data. Okay, let's go to here, try bake. First thing we need to do on try bake is go to, where was it? Environment, traffic design.clear. Okay. So now we clear the data and we try this again. Hey, there we go. And one last thing on this is after we've gone through this stuff, we're going to say, what is it? Editor utility dot set. What am I looking for? Dirty, set dirty. And we want the object, and that's going to be traffic design. That way the Unity IDE knows that I've modified data stored within that class. Back to Unity. Let's try this again. All right. This hold panel should have theme music, like Jeopardy. However, I don't think any place wants to draw attention to the fact that you're waiting longer, but I want to. All right, so it's collecting data and drawing it. It's still got the old data in it. Let's get it to do it again. Try. There it is. Okay, we've got a problem. This will leak meshes. Okay, yeah, that'll be painful. But right now we've got 1,000. So yeah, let's go back to the shared one. Oh, okay, that's going to be horrific on memory. I have to fix that or I will definitely forget it. So we're going back to shared memory. That wasn't the issue anyway. So shared. Second thing is when we're getting we're not getting the transform from the mesh. That's why all the positions are off. We're taking the transform of the procedural traffic generator, of the procedural traffic system. Okay, yeah, that is the problem. To get these positions, we need to do mesh dot, not mesh, filter. Much better. Okay, filter. Okay, that gets our positions. We have our positions. They should be in world space now. They weren't supposed to be vector, though that'll probably work the same. Or, well, it'll probably work well enough. Let's fix these ones as well. Okay, that should clear up the leaking meshes, and that should also, let's see, leaking meshes, that should also give us the correct offsets for all these positions. So final thing is try. And then I have to find the data. Where on earth is it highlighting things? Try. Ooh, what's this? Okay, it moved. Oh, look at that. That's mapping out to a building. Wait, is there really a model? There it. Oh, okay, yeah, it's down here. Awesome. Okay, that is a heck of a lot better. Okay, now let's try to get some more realistic data. Let's go to 10,000. We've got the grid showing up. Okay, now we're going to go to 1,000,000. And that should be all the city. Oh, maybe we're over 1,000,000 pieces of data. Oh yeah, and then these ones, there's not going to be as much on these huge buildings. You only have one in the corner. Why isn't there one here? Or in this building? Okay, it seems like 1,000,000 is limiting what I can show. Plus, I haven't done any merging, so the data might actually be higher than this. But I've got the right positions at least. So awesome. This is pretty close to what I was looking for. There will be a couple more changes that I have to do when I'm massaging the data, and I can see about how well I can get that to work. Additionally, this is going to be putting the data into the tool system, so I can actually go through, or someone else can go through and manually alter the design in various places to say this one's causing a lot of trouble. Let's modify that one. However, the only thing this affects is the traffic that comes through here, and so I might be able to get away without having to care about it too much. All right. However, I do want to look at what are these. There's a large grid of these points together. Oh, there's a lot of tunnel space here. Okay. Yeah. This is practically a grid of smaller city space. Cool. Awesome. How about what do we have here? 0, 2 million. Ooh, 3 million. Okay. 4. And this might go more. Let's add one more 0. 40 million. Um, Whatever it actually comes out to, we don't know. But that's really hard on rendering because we're producing 40 million draw calls or 4 million draw calls. But that definitely has the data where what I'm looking for. Excellent. Okay, now I need to stop the code or stop drawing it. That's excellent. Okay, I got to save this, save the scene. And now back into here, git add dot, git commit dash m, and here we are looking for traffic phase 1 per vertice, per vertex. That sounds awful. Per vertex, per vertex. Yeah, no. For each vertice. And git commit, git push. Okay. Oh, also, I do want to check one other thing. What is the size of this data? Let's bake it. It's a lot of data right now, and I should be reducing it down by at least 1/3. But this should give me something good to work with. So let's go to bake. Okay, that's doing its thing. I was expecting this part to take longer because it has more processing steps to do. Okay, and I am affecting the procedural one, but I am getting the data I expected. I just need to get the size of this object. Yes, baking. And now the baking needs to have a much longer time frame attached to it. I have no idea how long that's going to take. Well, I can at least take a look at the traffic data we had to begin with and see how close that is. I should assume it's only 1/3 of the design data, which would have less or more information than what we would have available at runtime. So let's go into here. Where do we have the actual code? Project, Vigilante assets, and Vigilante data runtime. Okay, this is it. Procedural, 37 megs. Okay, not too bad. And it's going to drop down to less than that. All right, I'm going to leave this to bake for the night. I should have put in something where it'll tell me how long it actually took. I will need to do something for time or to update the amount of time, but it's not like I need to bake that often anyway. All right, so yeah, done with the project for the night. All right, talk to y'all later.